Aquatic plants are considered as a given in our hobby. You can reach a bunch of different species very easily, very quickly. But it wasn't always like that, and the whole process of getting a plant into production and being able to sell it in big quantities, it's a lot more complicated than you think. So that's why we came here today, to get a lot more smarter people than me explain how it is actually done and how all these get into your tank. So here we are in Aarhus, Denmark at Tropica plants. Please join us on a journey where we're going to show you how plants are made and how they get from a laboratory into your very own aquariums. Helping us on this journey, we have Troels, the Chief Innovation Officer at Tropica, working here for over 20 years, having a PhD in aquatic plants. There is no better person to lead the way.
I think it's a great story to follow the plant and the different kinds of plants that we have in production. And roughly, we try to get in 200 to 300 species every year with the aim for that we can deliver 5 to 10 new products yearly to the market, to the hobby. And in this process, we take it first into test tanks in our test room facilities. And then when we think this plant is interesting, this could be good to have in our assortment, the next step is to take it to the laboratory and to see whether we actually can grow the plant from the laboratory.
Our first step is the laboratory.
When we take a plant into the laboratory, it's a matter of killing down bacteria, fungi, virus in the plant. So we have the growing part of the plant being free from any bacteria and fungi and viruses. And most often we don't succeed in the first attempt or the second attempt. We need to redo the initiation process, as we call it, to make it stronger, the chemicals, or longer time or short time. And then we continue doing it again and again until we see we have a few clean shoots in the end. And then from there, we build up the volume. Our purpose with producing most of our plants from tissue culture is that we believe in that that's the right way to do it. All plants are produced here in the house from the start, so we don't collect in the plants from the wild nature. The second purpose with doing the in vitro culture is that we can have a better control of always having the right number of plants for our production. The third reason is that we get plants that are free from any kind of diseases, snails. If we get a better plant to be used either directly in the grow cup for the customers or to be used in the greenhouse.
From the laboratory, the plants go into the growth room. Here we're going to have Hannes helping us, explaining what happens, whose main job at Tropica is to get plants prepared for the laboratory work and getting them into production.
The plants, you can imagine, come from our mother stock in a tub like this, and then will be only opened under sterile conditions. Then it's separated into smaller portions and then put into a conveyor belt where there is cups running along. These bigger tubs for our own production, they are not produced on the conveyor belt, but they are separated on a normal sterile bench, and then a new tub is started from the mother tub, so you can multiply this.
We had some tests showing that actually it could be a good idea to use liquid media instead of solid media for our cups products. The observations showed that actually you get a plant that is easier to be adapted going into the aquarium when it's on liquid media. A main difference on solid media and liquid media is that we don't put agar in the liquid media.
Agar is a gelatinous substance derived from the cell walls of red algae. While it's mainly used in plant production, pharmaceuticals and molecular biology, what might be a bit weird is it's also used in the food industry. It's used as a vegetarian gelatin substitute in jellies, puddings, ice creams and so on, as a thickener or stabilizer.
The agar is what makes the media becomes solid, becomes stiff in the cup. We have plants that prefer to grow on the surface on the media. So that's why we still have hard media in some cups.
Once a plant gets into a shop, its shelf life highly depends on the plant itself. Some are really quick, while others are really slow, just like their speed in the aquarium.
We have some plants, mosses for example, anubias, bucephalanders, they can stay in a cup in normal room temperature for weeks and weeks and weeks and months before they start to get lack of nutrients. While if you go on the other end where we have fast growing stem plants, they take up all the nutrients from the media in the cup, and especially if they're stored at room temperature in the shop, they will run out in approximately 10 days, 2 weeks. Actually, they will still grow and do well in the aquarium in the end, but if you just look at the product, you will see that it's start to in being a lack of nutrients. The shops store them at colder conditions, so we recommend 15 degrees in a cooler. Then we guarantee that all plants that at least can be there in the cooler for 2 to 3 weeks and still be in a perfect condition for sales.
With the modern ways of nurturing plants, all plants start their life in the laboratory, not just in vitro. And that's where these huge boxes come in, or that you see here. These are gonna be turned into potted plants later on, and there's another room full of in vitro cups that you already know.
Here we see one of our core rooms to stable production of many of our plant varieties. When we are talking laboratory production, we are having the initiation process that Trolls mentioned, and from that everything happens in vitro.
A lot of people buy, I don't know, 10 pots of Monte Carlo to grow a carpet. Why can't they buy a big box?
A small cup provides you with so much plant material that is more than enough for the general user. If you buy 10 cups of Monte Carlo, I guess you are planting at least 500-liter tank. It's gonna be an Iwagumi style, I guess. The racks have a slope, so the new plants coming out from the laboratory are just placed here, and then they can roll down to the other side. And on each of the trays, you have a little code with a big number on it. This one indicates
Production week.
No, this is the week when it's ready.
Okay.
So we are in week 37 right now, and this is Eriocaulon, Vietnam, and this should be ready for the pottery in week 43. Depending on the plant, the different growth speeds, we have a higher throughput or a lower throughput here.
Before we take into further production, we take a part of the plant material into what we call our gene bank. And the gene bank is new for us. We have had it for 3-4 years now. But the purpose of that is that all the species that we have in production, we have a backup in a gene bank in a protected area. We keep on propagating the plants, but in a slower speed, so we can try to always ensure that we have a stock of that specific species that we want to have in production. One of the purposes with the gene bank is that we know that for a given species, a Limnophila sessiflora, just to take that, there can be many different versions on the market of a Limnophila sessiflora. By having the gene bank, we know it's always the same plant that we can reintroduce into production if we, for some reason, loses the material that we have in production.
Can we actually take one of these and compare it with the other side, how the same plant looks?
Of course we can. Exactly. Oh, we can just try this.
I've just moved.
Don't worry.
The whole line.
It's fine. It's fine. If there's space, they can move. No.
I've optimized Tropica's business.
Thank you. This is Cyperus helferi ready in week 41.
Which is about 4 weeks from now.
This is exactly 4 weeks from now. And this is week 38. From Monday, this is perfect to take.
How many pots a batch like this creates?
This is probably, I guess, something like 20-30.
Time frame in here is different for the plants, right? So this was 4 weeks from back to front.
Yeah.
But for example, Bucephalandra, I guess that might be taking longer.
It all depends on not just the difference from front to back. It also depends on how much throughput we do have.
Okay.
So we adjust as well how much comes in. So it could also be that there's a whole lane where the code or the week where it's done is the same.
Okay.
And for example, you can see here for the Kedagan, we have 38 here. We have 38 here,
Okay, so it's all the same plant. I always knew that growing plants is a long process, but even for me, it was a surprise how long it takes for the really slow ones.
In total, we are around 100,000 units weekly we produce in the high season weeks. If you start with the most slow growing ones, is the ferns, Microzorum, Bulbitis. Roughly, from we need to guess what are we going to sell, that will be in 2 years from now when we start up with the ferns. In the other end, we have the floating plants being the fastest ones. That could be a Limnobium or a Savinia. Everything from down to 2 weeks. In average, around 4 to 5 weeks on many of the plants, and some plants being there for 6 months or longer.
I just saw a lane here where we have week 4 on it. So we are already in what is going to happen.
Already next year.
Yeah, exactly, because this is Microzorum pteropus.
This is what Charles mentioned, can take up to 1.5 to 2 years from start to finish.
Exactly.
It's even growing downwards. Yeah. What is the purpose of the membrane? I guess it needs to get air for this long process.
It's a semi-permeable membrane which allows gas exchange, but no humidity, like no water can go through.
Okay.
So we found out that the ferns especially, they profit from this, while the other plants, they can tolerate the more simpler tubs.
Imagine a tank using microzorums this size all around.
It's like a microzorum.
Yeah.
And no matter how small your tank is, if you let the microzorum grow for long enough, you will have this bush.
Yeah. This here, it's gonna get potted in about 4 weeks' time, which means that in about a year, someone's gonna be able to buy this from a shop.
Maybe not that long, I guess. Very, very small plants that you may want to attach somewhere. They are, of course, a little harder to handle. So you have tinier rhizomes, you have tinier leaves, so you are working with super glue and forceps and the plant in between, and then you want to have it stuck on the position you like. It gets messy.
This is Bulbitis. It's also insanely small. Could have crazy potential.
Yeah, but it will grow big, right?
I know, but it takes a lot of time.
In the shop, in the end, people will rather buy a cup that is full of plant with bigger plants than the ones that are just tiny. You know?
This is for
you.
Competition use only. This has insane potential. Just like in the world of houseplants, where we have some mutations like the variegated plants that became so popular during COVID, even in the aquarium world, we have certain mutations, and some of the plants that we use regularly nowadays, they just simply didn't exist in nature originally.
An example of a mutation of plant is this one, for example, with the Alternanthera rosanavi, where we have these variation in the leaves, where we can see the lighter nerves in the leaves. Vindeløv probably being the fern, Microzorum vindeløv, probably being the most well-known mutation, which were back here in 1994 in a greenhouse, that it was found on a table with ferns going into this Vindeløv mutation. So yeah, we have mutations. We try to be observative on whether we have them, and we always take them down underwater. We follow whether they keep this mutation. We also know that some mutations, typically with white colors in leaves, that they don't stay there, they're not stable. Others, we can try to keep them stable.
Which one is the plant that you have the most issues with?
In production?
Yeah.
The people in the laboratory, the hardest plants are the ones that form rhizomes that are hard to cut. So you can imagine that a moss or even like a fern with only a smaller, more frigid rhizome can be cut very easily and very quickly. For the anubias, you need to have much more force on the plant itself to cut it. So that gives our workers that are continuously providing highest quality lab-produced in vitro cups and tubs the biggest issues, because it's actual manual work to separate and propagate these plants.
Utricularia is one of those. Is it as difficult to grow in vitro to get to the shelves as it is afterwards?
I think it's easier in vitro than to grow it in
the plant that we call a 50-50 in aquariums. But yeah, I guess the production itself is simpler. While it seems that nurturing plants this way is, well, you could call it easy once you have all the technical background, why don't we have a lot more different species available to us?
I've been here at Tropica for 20 years, testing new plants for production. And there has over the time been many plants where we know that these could have a high sales potential, and where it has struggled us to get it into the laboratory and to get it in a controlled production. To give an example, right now we are, for example, working with bulb plants with the hope for that someday we can deliver a bulb plant from the laboratory. An example of plants that we haven't solved yet is Physidens, which is very well known in the hobby. And my best guess for why a Physidens is so tricky is that it is maybe only one cell layer or very few cell layers in the stems of the Physidens plant, if you can call it stems. So when we treat it with the different chemicals to get a cleaner laboratory, at the same time we also destroy the plant.
There's always plants that will fall through the grid for one or the other reason. Yeah. The plants are just too complicated to keep for the general aquarist, the general hobbyist, and there might be like a few thousand people in the world that are so nerdy, they will grow it and they will pronounce that is a very nice plant and it grows so easy. But it always depends, of course, on where you are in the journey of being an aquarist.
Once the plants get ready for the next step, the in vitro plants get to the labeling station where they just get the sticker and then shipped out immediately. The big trays get to the potting station where they get into their small pots and get transferred into the greenhouse to spend another 2 weeks to 6 months, depending on the species and their growth speed.
The plants come from the growth room that we just saw. They will arrive here to be labeled and go into the next rack, the expedition, where the orders come in, and then in a big circle the orders are fulfilled and plants are packed inside.
Last time we looked into how many countries we ship to, it is around 60 countries around the world. Most of the countries are in Europe. When we go outside Europe, it starts to get more tricky. Japan we also deliver to. And more paperwork and more limitations in which plant are we allowed to ship to that country. When we deliver plants out to the potting area from the laboratory, it needs to be the same quality and needs to be a nice carpet with plants to ensure that when they work with it in the potting area, that they know they can do it the same way every time. The origin of the plant is the same whether we take it out to the potting station or whether we take it into the cup.
Getting the plants from the tops, from the jelly, into the pots that you can buy them in is a well-optimized combination of human effort and automation.
Plants arrive in the tubs here. The trays that are reusable have been washed and dried. They go into the system, will be filled with pots. There is a robot that supplies the stone wool that is pre-cut. And then the people working here can just take a tray, and then they have pre-wetted stone wool, and you can see that they will work like in a really unified method to put the plant, the right amount of plant and the right height in the stone wool to have a very unified product. There's a lot of stuff happening automatically already, but yet again, it is still manual work because we are talking about biology, we are working with plants, and it is hard to teach like a computer all these different kinds of plants. What do they need to look for? How do they position the roots?
Browsing on the internet, you can easily stumble upon seeds for aquarium plants. But if that was real, why would you go through all this work to get these plants in this form?
When I started at Tropica many years ago, we had 5 to 6 different species that we produce from seeds. And to produce plants from seeds, you need to produce mother plants that can flower and produce seeds and then harvest the seeds from there to grow the plants. And it's quite tricky to get seeds from the plants in the right quality and to grow them into the potted plants. As a part of our search for new plants, we have also from time to time ordered what you can get of seeds out from there to test. Is there either a new species? Is there an existing species which we could buy in as seeds? And so far we have only experienced that it's not always the same plant as we had thought that we would buying the seeds, and it's typically making a carpet looking nice and green for a period, and then it dies underwater after a period of time underwater.
If you check out the pots, how they look now and how they look in the end, it's almost always like a very unified look. So this is part of the quality assurance in Tropica, that we have a product that no matter when you buy it, you will always have the plant in a very good condition, growing under very good conditions on our side, and then have the best start in your home tank. This is also some business that Tropica has a big part in, where people can buy grown-in ferns and anubias on wood or stone, which is perfect to start up a tank and have a good look straight away.
I think Balazs made a video where he used only pre-made, and then you can build a hardscape with the pre-made stuff as well. Besides having stability in the quality and the production of the plants, another good reason for doing in vitro is the ability to prevent plants being collected from nature. And that's not the only thing Tropica is doing for sustainability.
Here at Tropica, we are well known for producing potted plants, and we have produced potted plants since the 80s, beginning of the 80s. That's many years, 45 years now. Then we introduced here back in 2010 to produce it directly from the laboratory in vitro cups. And that has also been now a big success. Then here over the last year, we have taken up the challenge, how could we deliver a plant product in the same quality for the plant to the end users without using the pot and the stone wool, which is just waste. In this process, we came up with the idea to have this plant clip. We can grow the plant bare rooted out here on the production tables, and then in a packing station, we can place it in a clip, and then we can ship it in a bag out to our customers, and then they have a tray to log it underwater out in the shops, and then the end users can come here, buy this plant, go home, and then open the clip, and then they have it already bare rooted. They don't have to get rid of the stone wool, and then they put it on a place of wood or rock in the aquarium, and they can recycle this as a PP material. We believe in that it's an excellent idea, and I'm also confident that one day in the future we will do more and more plants bare rooted with all the good benefits, both in terms of sustainability, but also for the end users to have an easier experience in how to use the plant in the aquarium.
After being potted, the plants roll into their new home, the greenhouse. If I look at there, there's about a couple hundred meters of white tents. If I look at there, there's another couple hundred. And if I look underneath, there's tens and tens of thousands of plants.
So the plants potted in the pottery area and put on these big trays. We have, I think it's like 40 lanes or so. And we basically always start here in the beginning, and once a new tray comes in, they get pushed downwards. And in the end, we have basically the most ripened, the oldest plants that can then go into packaging.
Okay, and now we see like some water dripping on one side, but it doesn't on the other.
Yeah.
And I guess these plants also get fertilized frequently. So what's the system for that?
Yeah, so we have a big water cycle where the water is also reused. So we are saving a lot of water by just reusing it. And depending again on which plant we are talking about, we are positioning them in different parts of our big greenhouse, so they get different nutrition from the water that we are seeing running here. The lane decides on how often they will be watered and how frequently they will be submerged and drained. We also catch the rainwater, and then we put nutrients in it.
Or the spraying system above us?
Yes.
Does that just just shoots off sometimes?
Yes.
It needs to be with the humidity of the whole building?
Yeah. There is sensors for the light intensity, for the temperature, for the humidity, and also for the CO2. Since we are working on the larger scale, you can't do that manually anymore.
You might be thinking, we are adding CO2 into our aquariums. These plants need the CO2, but how does that work in nature?
When we take the plants below water, they get a limitation in taking up the carbon dioxide from the water. Actually, you talk about that if this is a leaf of a plant, then you talk about a boundary layer. For the plant to take up this carbon dioxide, the concentration needs 10,000 times higher concentration of carbon dioxide in the water to go through this boundary layer to get inside the plant. So you call it a diffusion barrier to take up the carbon dioxide from the water. If you go out in nature, then we typically work with the plants that are growing between the water and outside the water, what's called amphibian plants. And they have the ability both to take up carbon dioxide from the water, but they can also take it up through the leaves from the air.
You can see there's a bunch of different plants that are ready to be shipped out. Usually that the ripened plants, they come up here and then they are taken from the tray, the pot, gets a label, gets a sleeve, put back in here. And then this goes onto the conveyor belt and into our so-called plant hotel, where they are stored a little colder, not so much light, for the orders that come in.
Okay. Within this huge greenhouse, there's a very special tent. Let's hear Ralph how it all works.
The moss tent, basically a tent full of moss. It's very moist, and for some of you out there, it's probably wet enough to give you wet dreams, especially if you see all the moss in here.
How is this area different from what's outside? Well, we see all the sprayers getting, and I feel that it's a lot more humid.
Humidity is about 100%.
Okay.
So if you go to the regular nursery, humidity is about 75%. More like the others, also the moss we produce in our own lab. The moss portions, they're grown in here, but they're genetically like the ones we offer in the in vitro crops,
yeah.
so the one to grows. We put them on mats or metal grids to spread the tissue culture material out, and then it starts growing quite rapidly. So going from thin layer of tissue culture material, they adapt to the climate in here and they grow and get thicker carpet. We have the Christmas moss on a little piece of driftwood. We also do it in combination with hygrophila.
And how they fertilize? Is this through the spraying system? You actually give them fertilized water?
Yes, we also pump CO2 into the atmosphere. Despite we call it moss tent, it's not only moss. We also like to put bulbs in here. If we get imports from Africa, like up on a Gator Nymphaea, we like to put them in here because they start growing due to the high humidity despite not being submerged.
While the goal is to produce every plant in-house from start to finish, some of the plants provide a bigger challenge than others. So even today, some plants, especially the ones grown from the small bulbs, are still collected in nature, in the wild, and then imported and grown here in the nursery. Just like one of our favorites, the Nymphaea lotus.
We have done more and more cups over the last period of years, but we also have still a wide assortment in potted plants. And some plants we have both in potted versions and in cups versions. For the end user, it's also differing a lot what they prefer. Some they prefer to have still the potted plant, for example for Bucephalanda, because they find it easier to take this potted plant and place it on a piece of wood or rock. If I should choose, I would take more cups than potted plants, but it's also a matter of patience.
I'm sorry if all this turned out to be a bit too nerdy for some of you, but that's how it goes when you're growing plants on such a big level as this greenhouse behind me. thanks for Tropica for bringing us out here to get this done, and thanks for their help in getting this knowledge to you guys. I hope you all enjoyed this. See you next time. Goodbye.